we are going to give a bit of an introduction to CoinWeb in general. And after we've done the general introduction, Alexander will take over and talk a little bit more specific about use cases that you can build on CoinWeb, use cases that we hope that someone will make throughout this hackathon. But even if those use cases aren't things that you're building, we are very much open to any sort of idea or any form of sort of application or development. So it's not limited to the things that we're going to present here. But so what is CoinWeb? I'll give you a brief introduction. So we can start with the problem, because we have two very good brains behind the tech and the architecture. So we namely got Alexander here, who is our chief architect, and he has a background that not many people maybe know about, but he's been working with cryptography since basically the 90s, back when cryptography was illegal to export from the United States. But given that he's a Norwegian resident, he could export it from Norway, and got into cryptography already back then and started developing stuff. Built a very, very big search engine, and then went on to work for Google and led the teams that were developing both Google Hangouts and Google Plus and these sort of applications for Google. A little bit later, he found Bitcoin, and he actually patched the original Bitcoin core, and is mentioned in the Bitcoin GitHub for it. So he's a true OG when it comes to the space. But quite early on, Alexander and Knut, our CTO, figured out that there were quite a lot of issues with blockchains, and a big part being both scalability and the interoperability. But kind of what we see is that when you develop a blockchain-based application, you traditionally have to choose one blockchain. And when you pick a blockchain, you're normally influenced by some different factors. And this may be, speed of the blockchain, the cost of the blockchain, the reliability, liquidity, or even the ecosystem, both like dApps as well as community. And normally developers have to make a decision not based on, this is the perfect blockchain for us and what we're trying to build. But quite often, or most often, they have to pick a blockchain that has the fewest trade-offs. And that's kind of what we want to change. So what have we built? So we built a unique platform that offers developers like great flexibility. So when we don't really have our own blockchain, which is quite special, we don't have our own consensus system. What we've done instead is that we're trying to unify the blockchains in the space. So it's not just another L2 or another L1 that we built, but what we have built is a L2 that allows you to deploy things both on a L2 level in our L2, but also on a L1 level. So in summary, really, we do bring together the best of all blockchains in one space, because you can both pick your blockchain that you're developing on, but you can also combine different blockchain and build on them all at the same time. Let me see. So what do we offer to dApps? It's a very ecosystem-centric approach. And what do we mean by that? That means that you can build on CoinWeb and pick either one or multiple blockchain underneath for the consensus. And this provides you with quite unique features. So for example, when CoinWeb announced its partnership with BMW, the media attention was both for CoinWeb as well as BNB, that BMW picked as an anchor chain for their project that they were developing on us. And this means that you get this sort of exposure for the L1s as well, that enables you to really give them attraction to a point where you can basically apply for L1 grants whilst building on CoinWeb. And if you look at like Polygon, for example, if you build a application on Polygon, it would be very difficult to apply for a grant with Ethereum or Arbitrum, let's say, and you apply for a grant from Ethereum and Arbitrum, because it doesn't really give Ethereum a lot of attention. But building through CoinWeb, you actually can do that. We have a grant program. So we set up a $10 million ecosystem fund. The grant sizes are varying from $500, and that's obviously a very low number, but up to $300,000. And it really depends on what you're doing, what you're bringing to CoinWeb. But on the flip side, we're very much open for any sort of project to come and apply for grants. As you can see on the right side of the presentation here, we're very much open for anything, and we are very much a general purpose platform. And since we just launched this program, we're going broad on the target groups, and it's just because we want to get in projects from all different verticals, just because we want to showcase all the benefits that we can bring to each vertical. So what are the unique set of features that you can expect from CoinWeb? So we have cross-chain tokenization, where you can basically issue a blockchain agnostic token on CoinWeb. And we're using our cross-chain broadcasting system to basically send down the information to, so the broadcaster is basically our equivalent of a sequencer, but we don't have a sequencer. We use something that we call a broadcaster instead. So you can issue the token on an L2 level, and then you can choose what chains on the L1 level that you embed the transactions into. We've set up a blockchain routing system, which is very unique, I would say. So if you issue a token on CoinWeb on an L2 level, you can pick the chain that you embed the transactions into, where consensus is done, basically. And then you can set KPIs, which can be, for example, speed, uptime, or gas cost. And the KPIs are being monitored all the time. And if they are not met, then the system can automatically switch the chain or the underlying chain to be with a chain that actually meets the KPIs. So in case of an outage, for example, Solana goes down for a few hours, then you can use a different chain to transact on during that outage. Or if Ethereum gets too expensive, then you can use a different chain to transact on. But also if there's a serious event like Terra Luna, a complete collapse of the blockchain, in that event, you can also automatically switch to another blockchain. We got a wallet library, including fiat rails. The fiat rails are obviously not open for everyone, but you can basically take our wallet library, implement it, and then you containerize the tokens that are issued on our platform. And in the event that someone wants to have fiat on and off ramping, we also hold licenses for that, so that can be implemented into the application. We got gas fee abstraction, which is basically if you issue a token on CoinWeb, you can remove the need for users to hold separate tokens to pay for gas fees. And that is both with CWeb as a L2 token, that is the Apex token of our platform, but also for L1 tokens. So the users would not have to deal with that. They just use the dApp Zone token, and that's the only thing they need to transact with. As a L2, we're similar to rollups, where we can bundle transactions in our L2, and that gives us a lot more speed than what the L1s can do. So on EVMs, I would say that we go up to 10x of the speed of the L1 in terms of TPS, and the gas fees can be reduced up to 90%. Another thing about that is that if you issue a token on CoinWeb, you can load balance the transactions on two different blockchains. So let's say that you have a very, very high transactional dApp, and you know, let's say that you have 5 million transactions a day because it's microtransactions, then you don't have to put all of them into one blockchain. You can basically put them and spread them across all the blockchains that we're connected to. So with that, we like to refer it to something that we call horizontal scaling, basically infinite scaling. So you can spread them across all the chains that we're connected to, and as soon as we add a new chain, that can be utilized for it as well. We got reactive smart contracts, which is smart contracts that can hold gas balances, and they can monitor all the events on all the blockchains that we're connected to. And because it can hold gas balances and react to it, it can basically self-initiate things based on the events on the L1s. A good example of that is our staking program on our ERC20 token, whereby a user can stake the token in a non-custodial way. So they basically go into their wallet, or they have their wallet, they go into our dashboard, they basically just sign a message that they're staking. And then the parameters that we've set on that staking program is that they can move tokens into the wallet, but as soon as they move tokens out of the wallet, they automatically unstake and they lose the rewards that they've accumulated. We got token shields, and token shields is a very smart setup for basically existing bridges. And if you're bridging token through existing bridges, we have a way to track if you know tokens are minted falsely or etc. But Alexander will go more deeply into this one. We have something that we call unified development, which is basically something that relates to us having a VM on top of ourselves called WebAssembly, which basically allows you to integrate with CoinWeb in 40+ languages. And it also makes the dApps more compatible with common devices and applications. So unified development really just means that we can bring in a lot more developer talent pools to our protocol than, you know, having just Solidity or just Rust or Haskell with Cardano, for example. You know, they struggle really hard with basically getting people to develop on the chain because of the choice of language that they develop the chain in. And then backend and reporting, we can provide backend system. We have that set up for ourselves, and it's also something that we can help with. Moving forward, so what are the connected chains today? So we don't have any limitations on what chains we can connect to. We're always seeking for feedback on chains that we should connect to by the developer community. But today we have Bitcoin, Bitcoin Cash, Ethereum, Litecoin, Arbitrum, BNB Chain, Polygon, Multiverse X, Kujira, and Doge. And then we got a few more chains coming. So here we see Solana and Base that are they're basically in the development queue. So scaling blockchains horizontally, we touched upon earlier. What do we mean by that, really? This graph kind of shows the actual scaling that we do utilizing the consensus of the underlying L1s. So on BNB, for example, we take it from 3,000 to 32,000 transactions per second. Matic, we go from 700 to 12,000, and Ethereum from 27-ish to 2,000. And then our max TPS on our platform is all the chains combined scale max TPS, since we can load balance traffic across all of the chains. So we do generate more value to applications. And why do we say that? It's basically because the applications built on CoinWeb, they have full L1 data availability, which basically means that they can merge all the data from all the chains that we connect to and basically provide that data to their users. So it's really unconstrained value generation for the users of the applications that are building on top of CoinWeb. Yes, Alexander, and you will have to let me know when you want me to change to the next slide.
Yeah, thank you. Thank you. So I wanted to start with this slide for all the developers. Please join the Discord channel and the interoperability channel, because then there you will find all links and things like that for what I'm going through. So yeah, next slide. So one concept that is interesting to use in CoinWeb is the pacts. So we developed pact as a concept. So you can say you go into a pact, you do a cross-chain pact. Pact means you promise to do something, and across two different or more blockchains. And this is a mechanism. It's a concept that can be implemented in a few different ways, but it shows some of the possibilities with CoinWeb. For example, some of you might know Thorchain and swaps that happen cross-chain based on a bunch of infrastructure and other chains, observers that observe stuff on blockchains and report to some chain that might be specific for swaps, for example. Pacts generalize this because CoinWeb smart contracts have the ability to block on certain events happening on the L1, and what you do with those events can be programmed as you wish with smart contracts. So pacts, penalty adjudication for cross-chain transactions, is that you have observers that we call chain transaction sentinel contracts that observe events coming in from, in this case, you have transaction X from blockchain A, and you have another chain transaction sentinel watching for transaction Y on blockchain B. Let's say there's a swap where you want to swap Bitcoin for Ethereum, as kind of a standard example. You have somebody initiating that. Somebody might start sending Bitcoin to a certain address, or they might start sending Ethereum to a certain address. When that happens, the other party needs to do their part of the swap, sending Ethereum or Bitcoin, depending on who actually started it. This is the pact. The way it works is that these chain transaction sentinels, these smart contracts that react to an event, they are sitting on top of a shard that has access to events on blockchain A and blockchain B. When they get these events, they send it to the adjudicator, and the adjudicator basically is a smart contract that figures out, did the participant do what the pact was supposed to do, or what they promised to do? Did I send a Bitcoin to the other person? Did he send Ethereum to me? And attached to the adjudicator in the pact concept, there is collateral. The collateral is set up either by, it's typically set up by the one that wants to be, let's say in a swap, the market maker, or the one that does not want, the one that does not want to take the initial step. So there could be, if the swap can be initiated by either party, then both put up collateral. If there is a market maker saying that if you send me Bitcoin, I'll send you Ethereum, then that market maker, or if you think in terms of a centralized exchange, it would be somebody putting up a limit order, would be the one providing collateral, while the one doing a take would not provide collateral. So the adjudicator decides whether the pact was done correctly or not. And then if it is done correctly, then the collateral is released back to the original owner of the collateral, and everything is fine. If the pact is not executed correctly because one of these external actors did not do what they were supposed to do, then the collateral is given to whoever was wronged in this situation. So pact is something we talk about because it enables a wide range of cross-chain operations, whether it's swaps, it could be centralized sales. You might have NFTs where you want to be able to sell them for Bitcoin as well as Ethereum or Bitcoin Cash or whatever, all sorts of ERC20 tokens on different chains. You can auction off things across multiple chains and all sorts of things. Anton mentioned non-custodial staking. You can observe what is happening on L1s and issue reward tokens based on behavior, and lots of. Not all of these require collateral. So actually, some of the things I mentioned are more just reactive smart contracts. But a lot of these cross-chain issues where you have multiple external actors that need to do something, then the pacts are what you want to use. Next slide. So here are some example things that we just came up with as that could be interesting to look at for look at. So here's one where you want to do a swap, but you want to facilitate an already existing, so this optimistic swap. You use price oracle. Basically, you can use, for example, Uniswap as a price oracle. You can listen to those prices that exist at the Uniswap level, and then you can say that, okay, I'm willing to swap at the market price that Uniswap provides as a price oracle, or whoever is in the pool can swap at that price, and thereby have a simple way to not deal with the price, or always provide a price that is better than Uniswap, while at the same time being able to execute it with lower fees. That's one example how you can utilize L1 events to feed into some other mechanism. Yeah, so that's it. Let's go to the next slide.
Go.
Yeah, we can go to the next slide.
Yeah, this is the next token shields.
Oh, sorry. Yeah, token shields. It was on a previous slide. Token shield is a more advanced way of listening to what's happening on L1. In the token shield concept, you basically listen to, for example, ERC20 events, and you build up a mirror of what tokens. So you can do it at several layers. You can build up a complete mirror of ownership structures at L1, but you can also start out with just keeping track of the number of tokens minted and burnt at L1. So let's say that you have a token that you want it to exist on multiple blockchains, and your invariant is that when you burn a token in one L1, you can mint it on another L1, but you want the total number of tokens to be limited across multiple blockchains. In this case, you can look at the minting and the burning across these multiple blockchains and see if that invariant is held. So if you take it a step further, you can keep a track of the holders of the tokens across the different blockchains. And you can see if there's a minting that did not was not according to that invariant, so some fake tokens were minted. This typically happens when there's a bridge, when there's a break of a bridge hack. And in this case, you can start tracking where those fake tokens are, and you can have a backup plan whereby you go out and you say, okay, this bridge was broken, there was a hack, which has happened multiple times. And what you let the users do is you let them burn their tokens in order to create CoinWeb L2 tokens. And then only those tokens that were actually not polluted by fake tokens are possible to redeem as CoinWeb native tokens. And this can automate the whole kind of recovery process around bridges and when they are broken. So this is a concept around securing and monitoring bridging systems. Let's go to the next concept. These two are more in line with what I think is fairly straightforward to implement in this competition. There's a lot of infrastructure and CoinWeb that's open for grabs. The first one on the left is basically DAO structures, voting and dealing with DAOs. That is something that is fairly straightforward to do based on the tutorial or the tutorials that we have. And another thing on the right are these collateralized debt positions. Many of you might not know what collateralized debt positions are, but they're basically that you put up some collateral, and then based on how much collateral you put up, you are allowed to issue a token. For example, MakerDAO or a lot of synthetic tokens are like this. So, for example, creating a synthetic Bitcoin token on the CoinWeb layer, which is cheap to transact and can be moved across to different L2 layers, different shards, and thus interact with certain events. These kind of tokens can be very, very useful for the CoinWeb system. So this is something that if somebody's interested in looking at that can be very interesting. Sorry, some question. How does Pact system handle disputes in cross-chain transactions? So the trick about Pact is that the state of CoinWeb is defined by what happens in L1. And this is not like it's not like most cross-chain systems which have a bunch of cross-chain systems have a third-party chain where you observe something, and then a bunch of observers vote on whether something happened or not happened, and then they place that on a third chain, and then there's consensus around that and a lot of collateral and stuff like that. That's not how CoinWeb works. CoinWeb instead is, and what in database systems is called an eventual consistent system. And whenever there is, for example, a L1 reorganization. Let's say there's a reorganization at Bitcoin, for example. This changes the state of CoinWeb. So then CoinWeb rolls back if there is a change in L1. And the L1 directly, so the L2, the state of CoinWeb, is directly computed based on what happens on the L1 chains it's connected to. There is no way to change CoinWeb without going through one of the L1s. So in order to get something done on CoinWeb, you have to embed the transaction at the L1 layer. And this might create a problem. You might see a problem with that, and that is that what happens when you have multiple blockchains and one blockchain is has a few rollbacks or not a strong consensus, and how can you then change the state and go back in time and things like that. So the way CoinWeb handles that is that there are multiple shards in CoinWeb, and there is a time delay when you send information from one shard to the other. So you have one shard sitting on top of Bitcoin that is absolutely determined by what happens on Bitcoin. And there is one shard, so if Bitcoin rolls back, then that CoinWeb shard also rolls back. Then there's a separate shard sitting on top of Polygon, and another one on Arbitrum, and another one on Ethereum. And these shards communicate with each other, but there's a delay in that communication. That is state propagation graph. We call that how state is propagated. And the fundamental property that CoinWeb utilizes that nobody else utilizes is that when you go back in time on a blockchain, if you go far enough back in time on one blockchain, the security is equal to the latest block on another blockchain. So that property, that even if Bitcoin has stronger consensus than Ethereum or Arbitrum, if you go back in time to the block that happened last week on Ethereum, the consensus around that block from last week on Ethereum is stronger than the consensus around the last block in Bitcoin. So that property is used to avoid this, to kind of secure the communication between the shards. So in Pact, what the adjudicator computes is directly computed based on what's on L1. There is no consensus around it. And how you know whether something is true, if you have two competing nodes in CoinWeb that says that the state of CoinWeb is different, then we use a system called referee delegation of computation to figure out which state is correct instead of consensus. And that way we keep the strength of the L1 consensus without putting another weaker consensus on top of it. So that's a little bit of like the theory behind how CoinWeb works. Okay, let's go to the next slide.
Sorry, here we go. Let's see, yeah.
Yeah. So reward pools. So this is like if you have a token and it exists on multiple blockchains and you want to reward some sort of behavior, let's say somebody that holds a bunch of them, or they swap, or they do something that you can observe, you can block on those kinds of behavior in a smart contract and issue a token on CoinWeb to reward things like that, and then connect that to a DAO and things like that. And then there's a bunch of DeFi infrastructure like lending protocols or AMMs and things like that that can also be built on CoinWeb. With the additional twist that you can typically get L1 tokens into your system. So, for example, you create an AMM where you can put in both Bitcoin and Ethereum into the AMM, potentially through collateralized debt positions that give you a first synthetic token. And the reason for that is that then you can trade much faster. But then you can use that in an AMM, or you can use pacts and things like that, and put that into the protocol. Next slide.
Yes. So we got a few questions though. So maybe we should answer them.
Questions.
Right?
Yeah, let's do that.
Because the next slide is, so we got, how can I access and use the full L1 data availability features to build my applications?
So you can, so from, I'm not sure exactly how to answer the question, but you can put your smart contract on top of multiple shards so that they can, or you actually don't need that. You can put your smart contract on one shard and you can feed it. It can be fed data from different L1 blockchains. So you can put your smart contract on the BNB shard, for example, and then you can feed it transactions from Arbitrum, Monk, or Polygon, or BNB. So you have that ability directly. And the way that works is that you create a transaction for the user in your dApp. You take the normal transaction as it would be in BNB, or how it would directly call your smart contract. You wrap it in what's called a jump, and if you wrap it in a jump, you can put it on Arbitrum, for example, and then when it's executed on the Arbitrum shard, it will be put into the queue to get to the BNB shard. It will jump to the BNB shard, and then it will call your smart contract. So that's just being able to use these availability options is basically messing around with how you construct the transaction and send it off to the broadcaster. And last, what are you looking for us to build on this track to win?
To win, nice one, and one, right?
Okay, nice one. So to win, I think, I mean, there's a lot of at the current state in CoinWeb, there's a lot of DeFi stuff that doesn't exist. So a lot of these stuff that I showed are DeFi, but a lot of social things as well. I think DAOs and ways for people to come together and do interesting stuff. Like it could be make it very easy to launch something, or to it could be to talk about projects, how to crowdfund or launch things, and things that help other developers succeed on CoinWeb. I think that would be great, and things that grow the community. That's something that, or in general, if something that helps the wider world, that's all of those things would be things I think find important, at least. Okay, let's continue. Yeah, so I hope you're all on the on the Discord channel so that you have access to the links. I was planning on showing a different screen now,
Do you want
Anton,
me?
because we're on the,
For sure.
yeah, let's see.
Sharing.
Let's see if I can manage.
Let me know. Let me try to disconnect. I'm not a big user of. Have I disconnected my screen?
Yeah, I think you have.
Yes. Yeah.
Let's see if I can share this image. This is our slide deck, right? You can see the slide deck.
Yes.
So I want to go through a little bit how to get going. You will be working on the DevNet, and one tool that you will use is the Explorer. And DevNet is a network where there are two Ethereum blockchains. They're called A and B. So when you have two Ethereum blockchains, you can test, for example, a cross-chain swap between two Ethereum networks. If you, for example, deploy Solidity contract in both of these blockchains, you might have those, or you can deploy normal ERC20 contracts for an Open Zeppelin or something like that. You will be able to observe events from these networks, catch them in your smart contracts, and communicate between the shards and do interesting stuff that's cross-chain. You don't necessarily have to do cross-chain stuff, but this is where you will find that there are lots of opportunities for things that have never been done before in this space. So if you go into the Explorer, you can see one transaction here. You will, when you deploy your contracts and you interact with them, there will be transactions coming up here, and you can find the transaction ID here. And let's see, I'll just initiate opening the transaction view, and you can see a transaction. Like, it takes a while to load, so I'll just go to the next slide. There is a token visualization tool here where you can see how smart contracts are executed on CoinWeb. CoinWeb is a little bit different from what you normally use on the EVM, and this looks quite scary. I would expect, but it's not that difficult, because you can start out. I'll come back to what this means. You can just start out by going to the documentation site, and it will all be clear, hopefully, and clear as mud. And when it's not very clear, then you can ask in the Discord. We'll try to answer as soon as possible. The tooling that you will use is typically TypeScript or JavaScript, and Yarn. In our examples, we use Yarn. You can also use NPM. And there's a tool called CWeb tool that you use to interact with DevNet. And then you use the Explorer and things like that. So there is a tutorial. Under tutorials, we have a couple of tutorials. We'll try to add more, but the string processor tutorial is the best one, I think, to start out. It looks like this, and the tutorial is actually a dApp that you can clone and play with. You can run this locally. The string processor tutorial gives you the tools and everything you need in order to create a smart contract that simply takes a string and reverses the string, or it does some other things. You can choose what you want to do with the string. Like, I think you can uppercase the letters and things. It's not important what it does. It's just that there is smart contract that is put into a contract module. And the contract module is a concept where you have an on-chain smart contract written in JavaScript. You have an off-chain interface code, like the API that you want to expose for your smart contract. And in the examples that we have, you also have a React UI that interfaces with your contract. And this tutorial shows how to do this, how to create a handler, for example, that reacts to when you call the smart contract and you want to reverse the string, how to pass, how to store data. This is storing data, and how to call other smart contracts, etc. So this is all in this this tutorial, which you also can clone. So in this tutorial, you have in let's say some of the steps. It's also how this tutorial is interactive. So this part of the tutorial is using the contract module that the tutorial explains how to create. So this tutorial is also adapt in the sense that when you do things, you affect and you read and you write and you send transactions to DevNet. So I wanted to go through just a little bit how, let's see, where do I have my, yeah, let's wait until this loads. Or I can just go back to this visualization. Okay, when you look at the execution in CoinWeb of smart contracts, the execution of smart contracts for a given block, let's say this is block 14422, works by invoking smart contracts or by executing transactions, and transactions can include reads and writes and updates to the storage system, and these are called read, store, and take operations. And they can also, these transactions can also call other smart contracts. Let's just check. Are there any questions? If there are questions, so Anton, please jump in. So a transaction, for example, this transaction, in this transaction, it takes some data from the storage system. It also writes some data to the storage system. These are called claims, and it calls two smart contracts. These two smart contracts are called in parallel, and smart contracts do not themselves change the system. They're not allowed to change anything except by issuing new transactions that can store things. For example, this smart contract, if you see my pointer, I hope you see it, it creates a transaction that stores data. So we can say that this smart contract stores data, and one piece of data in the storage system. This other smart contract, it creates a transaction that stores data, but also calls another smart contract. And if we go further into this call trace, we can see that there is a transaction here that calls that includes a call operation that takes, in the next transaction, it takes data from storage system and it also calls two other smart contracts in parallel, which themselves create new transactions, etc. So this trace, and you can, using the transaction visualization tool, you can go into each of these. You can scroll down a little bit, and every piece of data regarding what is happening as inputs and outputs and arguments to the smart contract can be found in by looking at this JSON structure. And when you create a smart contract, it is basically a JavaScript program that takes JSON as input and it provides JSON as output. And the JSON as input is data coming from the storage system, like this is the information from this key and that key and things like that. And the output is transactions that tells the storage system to write this key or take this key and call this smart contract, etc. And the reason why we have this way of executing in CoinWeb is that it allows for parallel execution. So this is an example. There are two contracts running at the same time. And it also allows for running smart contracts forever. And the way that works is that the smart contract can issue a new transaction that calls back to the same smart contract. And that way, the smart contract can live forever. The smart contract can also call itself. And in the same transaction, it can add a block operation, which delays the execution back to itself until something happens on layer one. Let me see if I can, yeah. This is a list of what a transaction can include in CoinWeb. It can use, so a transaction consists of operations, and these are the operations that it can include. It's data, which just passes data along, read, which are database lookups, block, which delays the transactions until a bunch of events are true from L1, like somebody sent an ERC, somebody received an ERC, something happened on Bitcoin, something like that. Take operations, they read and remove things from the database, and they also fund the further execution of the transaction because database values can include CWeb. There's store operations, which store into the key value claim database, and then a call, which invokes the next smart contracts. You can have any number of these operations. So that is a little bit on the semantics of CoinWeb. And that was basically, that was basically what I wanted to show. I wonder if there are questions regarding this. So if we don't have questions, then I guess you will have questions later, or if you view the recording. And then we are available in Discord,
Yes.
in the
So
interoperability channel.
exactly. So everyone, please join the GD or the next top blockchain startup Discord. Join the interoperability channel. Ask us any questions you may have. We will respond. We will try to basically help you understand CoinWeb to a point where you're very comfortable developing on us. It's a very different protocol compared to what exists in the market, but we're here to guide you through it. So just shoot us messages in that channel, write to us, we'll help you. And don't forget to follow us on Twitter, CoinWeb Official. Please do, please do, please interact with us. All support is very much appreciated. We're in a very, very interesting phase of our development. We're signing up projects on a daily basis almost. We have projects going live soon. So yeah, please support us. We're more than happy to support you guys for supporting us as well.
Awesome. Thank you so much, Alex and Anton. It was a great presentation. Please, if anyone has any questions, we dropped the Discord link on the chat. This meeting will be recorded and wrapped up and posted as soon as possible. Thank you so much, everyone. Let us know. Please join Discord. Let your friends know about the competition, all the tracks. We have over $240,000 in prizes. Let's keep building and growing. Can't wait to see your project submissions and what you're going to build on CoinWeb. Thanks, everyone.
Cheers, guys.